probably late afternoon your time. It's about 7 a.m. here in Philadelphia. Very happy to be here. Somewhat sorry that I couldn't be there in person with you, but we're still living in somewhat strange times, and looks like we're gonna maybe going through some kind of economic storm soon as well. But one of these days, I certainly hope to be there with you. It would be certainly an honor and a privilege. So without further ado, I'll do a little bit of introduction of myself. My name is Reza Rahman. In my day job, I'm Principal Program Manager for Java on Azure at Microsoft. Basically, I work with a number of different teams across Microsoft that do bits and pieces of Java. In fact, the thing that I'll be talking about today is one of the teams that I work with, namely Azure Cosmos DB. Don't worry about it if you haven't heard it before. Obviously, I'll talk a bit about it, and I won't be making very many assumptions about you knowing much about Azure Cosmos DB. Uh, Aside from my day job, I'm pretty active in the enterprise Java community. I have been for many years. So actually, the other part of this talk, aside from Azure Cosmos DB, is from that community. Namely, I'll be talking about a brand new specification as part of that's just part of the Jakarta umbrella and part of the Jakarta EE umbrella, and that is Jakarta NoSQL. So really, this talk is about how to use Azure Cosmos DB, which is a NoSQL provider on the cloud, provided on Azure, and how to take that data store and make use of it from a Jakarta application using this new standard Jakarta NoSQL. So let's dive right into it. If you cannot see me or hear me, or you cannot see my screen or something of that nature, give me a holler, please. Let me know if that is the case, and we will fix it. And I'm gonna stop sharing my screen for now. I'm gonna do a little bit of a hide button and move to our slide deck, which is where we will get started. So let me start the slide deck. So as I started the slide deck, hopefully you're able to see it now. If you cannot see it, hopefully one of the moderators will let me know that there's something wrong with my screen setup, but presumably there's nothing wrong. So we'll just keep moving forward. One of the things I will note for you is please don't hold questions until the end. Do ask me questions throughout. I will be checking at least a chat functionality, and hopefully the moderators can stop and let me know if are any questions outstanding, and I'll just answer those questions as we go along. So no need to hold back. Whatever the Q&A mechanism is, just go ahead and do it. I probably won't try to save time until the very end. I'll just do Q&A as we go. Okay, so as I mentioned, you can see the title of the talk. Again, this talk is about how you take Azure Cosmos DB, which is a NoSQL database running on the cloud, on the Azure cloud in particular, and how you use it through this new standards-based API called Jakarta NoSQL. All right. So what is Jakarta NoSQL? Well, as you can imagine probably from the name, it is a Jakarta specification. It's a specification that is part of the Jakarta EE umbrella that allows you to have a uniform API to access all manners of NoSQL databases. So if you don't know what Jakarta is, it is basically the technology that used to be known as J2EE or Java EE, used to be developed by Oracle in the GCP. Few years ago, moved to the Eclipse Foundation, and we just had a brand new Jakarta release. If you haven't heard of it, Jakarta EE10, and this is one of the specifications that is being developed under that umbrella. It's not quite 1.0 yet. It will be very soon, probably in the Jakarta E11 timeframe. It's going to become a 1.0 specification, but it's been actually around for a while now. I've developed it even for a demo application, and it actually works just fine. I know other people that are using it in production as well, and they're also successful with Jakarta NoSQL already. So although it's not 1.0 yet, it's a fairly stable release. You'll see when we look at the Maven history and sort of the Maven versioning in just a moment. So as you know, standardizing an API for NoSQL is not an easy task. It's not like relational databases where there is a uniform standard like JDBC or ODBC. And each NoSQL provider's API looks very, very different, and they all have slightly different features that they provide as part of their databases. So creating a uniform API for something like this landscape is not that easy. But it is doable, as Jakarta NoSQL is able to demonstrate. But the way you do that is actually you need levels of abstractions. At the end of the day, having one API to rule them all means creating an abstraction. But the way Jakarta NoSQL handles the diversity in the NoSQL databases is by having multiple layers of abstractions. Okay, so this is how we can manage complexity and still have a uniform API at whatever level that it is that you're talking to a NoSQL database. So the first is that is absolutely needed to provide a uniform interface, and that is a communication API akin to JDBC. Okay, a layer above that is a mapping and template API similar to Jakarta Persistence or JPA. And then above that is a repository API very similar to Delta Spike or Spring Data, whatever you may be, in particular Spring Data JPA is what we're talking about in terms of the repository API. So that's one level of flexibility, right? So this allows you to talk to many different databases in slightly different levels by having these levels of abstractions. In addition to that, another way Jakarta NoSQL adds flexibility to handle, again, the diversity of NoSQL databases is essentially by having different flavors of Jakarta NoSQL, but not many flavors, just a few flavors. So these map to, in general, the classification of databases, NoSQL databases that are out there. So there is key value pair, and that is simply, as you can imagine, a key and a value. You have an object in your database, and then you have a key for it, and you can retrieve that object via its key. That's key value pair. Then you have column family. So this is a variant over key value pair, where you're still accessing the database data using a key, and the data essentially is sort of a value stored that maps to that key. But that particular data is columnar, right? So you can actually understand that it's not just a blob data. That data is split up into columns as well. So you can think of an object that is actually more like a Java object, where it has data fields. So that's what a column family database is. And then you have document. A document goes beyond simply name columns, as in just a linear list of fields, but rather complex structures within the data, and again mapped through a key. And then finally, you have a graph database, and that's a sort of the most exotic variant of a NoSQL database that maps relationships. So in this particular world, just like we have relationships in the relational databases, relationships are a very important part of this type of database that allows you to navigate via those relationships. And then within each of these quote unquote nodes in the graph, you will also have data fields, just like you would for any of the other variants of databases. So again, multiple layers of abstraction, and then multiple flavors of the API, but not many, just four different flavors, and each mapping to sort of the larger scale taxonomy of NoSQL databases. That's how Jakarta NoSQL works. Aside from this, there are some other interesting features, very similar to sort of what JPA provides. So you have integration with the bin validation API. So you'll be able to express what is valid data using annotations. And we'll see an example of that, when we get to the demo. And you also are able to do some level of externalized configuration. So just like in JPQ or Jakarta NoSQL, you can configure your NoSQL provider using basically name value pairs. You can essentially do the same thing here with Jakarta NoSQL as well. And again, I'll show you an example of that in a moment. Okay, so that's about enough of an introduction. So Jakarta NoSQL is a standard. There's only one implementation of it right at this moment. It's called JNoSQL. And basically, if you go to the JNoSQL site, you will see that that implementation actually provides support for a whole bunch of databases, right? NoSQL databases, from Cosmos DB, which is the one we'll talk about today, to MongoDB, to Cassandra, to a whole bunch of databases. I will say, probably out of all of the Java APIs, this may be the API that supports the most amount of NoSQL databases. right? So quite a bit of diversity in terms of the type of database that you want to support. Very valuable if you happen to be a NoSQL user of using one of these let's say lesser used NoSQL APIs. But very good coverage so far, and only growing, only improving. Okay, so before we dive too much into Jakarta NoSQL, and it is important to talk about the NoSQL ecosystem a bit, right? So a lot of people, when I do this presentation or in general talk about Jakarta NoSQL or NoSQL in general, ask me, okay, well, what is the applicability? Like, how does the ecosystem actually look like? And a few years ago, it was a sort of a difficult question to answer because there was this mindset that somehow NoSQL databases are going to take over all of the relational databases, and it is going to become the de facto way of accessing data, and so on and so forth. But that actually did not materialize in all reality, and it doesn't look like it is going to ever materialize. So this is I'll demonstrate my point. By what do I mean by that? So this is a Google Trends graph, and you can take a look at similar graphs for along the lines of job skills, and you'll see mostly the same kind of data. So as you can see, there was a period of time where NoSQL demand was growing, right? I would say this is between time period between around 2010 to around, let's say, 2015 or so, right? You saw sort of a growth, a general growth in interest in NoSQL databases. Then what happened is around, let's say, 2016, 2017, things began to level off, right? And that's where things are at the moment, right? So NoSQL interest isn't really growing anymore. It's sort of like remaining on a steady curve. If you look at the Gartner hype curve, basically it means that this technology has reached its target market, right? So that it is sort of, you kind of know when to use Jakarta NoSQL at this moment, and begin to separate the hype from the reality, if you will. Now, if you also notice, there's another interesting trend here. So what I've done as an exercise is actually put in all of the NoSQL engines, in Google Trends in this case, to see what kind of data do I observe. And the data is fairly clear, right? And hopefully it is very clear to you as well. So by far, the most popular NoSQL database is MongoDB, right? This has always been the case. MongoDB has effectively dominated and almost defined what this NoSQL market is all about, actually, and hence, to some extent, the fate of NoSQL is tied to the fate of MongoDB now. As you can see, it's by far the most popular NoSQL database. Then behind it is something that actually is not quite a NoSQL database. It doesn't define itself certainly in the NoSQL boundaries, and that is Redis. Redis is mostly a cache, right? So you can think of it as a name value type of NoSQL database. But then it's all the rest, right? So the dozens or so other NoSQL databases, they all fall like far below the curve, below MongoDB and below things like Redis, right? So this is all kinds of things like Cassandra, HBase, Neo4j, RIAC, etc., HBase, and even the ones from some of the other traditional vendors like Oracle, IBM. They all fall like in that low curve of usage, right? Whereas clearly MongoDB is a market leader, and then you have things like Redis that are not quite NoSQL databases, but you can classify them as such if you want. And certainly Redis you can use via the Jakarta NoSQL API as well. Now, the other important bit of data to bear in mind is how is it faring compared to the traditional databases, right? And there's actually a website that does exactly that. You can look it up yourself. It's DB Engine Ranking. And this, again, there's a very clear picture that emerges, right? So definitely NoSQL is not going to be unseating relational databases any time in the future, right? You can see the graph here. So MongoDB, that is a clear leader in the NoSQL space, is not even in the top 5, right? So the top databases are things like Oracle, MySQL, MySQL Server, PostgreSQL, and they're remaining popular, right? So you can see those are the only ones that are above the 1K line in this graphic, and really those are the market leaders in terms of databases. And then you have things like MongoDB, right? Way below, way farther below the line, and all the rest of the NoSQL databases, they're not even they don't even make the 1.1 mark, right? So they're far below the graph here. Again, it's very much dominated by relational databases, right? So the only ones that are above the cut line here are things like Cassandra and MongoDB, and that's about it. Right? So the rest of it is all your traditional databases. So what does that mean in terms of what do we think is a use case for this technology? So by and large, if you're developing an application, you probably should start with the relational database, right? So relational databases are the norm. Most likely, when you should begin considering a NoSQL database is a couple of different conditions. One is that you have data that is in the order of terabytes or more, like more along the actually lines of petabyte range. At that range of data, you can no longer effectively store and manage data using a single database machine, right? Or even a small cluster of database machines. You do need to introduce sort of a distributed database. That is a very good use case for NoSQL, no question. Or if your data truly is unstructured, right? So it cannot be easily put into the structure of tables and that have relationships between them and constraints with them, which is what a relational database truly is. That's when you need to think about NoSQL databases. Those are the two primary use cases where you really would consider NoSQL. And that basically maps to the fact that it is specialized, right? You introduce NoSQL databases when you have a specialized data storage need. By default, really for the most part, you should still continue to stick with the relational databases of some kind. So having said that, though, let's assume that you do have those use cases for a moment, right? And you should be using a NoSQL data store. If you do so, what does Azure Cosmos DB give you? And what is Azure Cosmos DB? So let's spend a little bit of time discussing that question for a moment. So Azure Cosmos DB is basically what is called a multimodal NoSQL database. Okay, what does that mean precisely? So Azure Cosmos DB is, again, a NoSQL database that is running on the cloud, and it is a cloud-only database. And in fact, it is a single cloud-only database. It is only available on the Azure cloud. But what it fundamentally is, at the core of it, is an engine that allows you to store data. But this engine actually has multiple APIs that it supports, right? So all of the different APIs that Azure Cosmos DB supports are something called SQL Core, which is a subset of SQL. Very recently, in Jakarta Cosmos DB has also introduced a PostgreSQL facade. There's also a MongoDB facade. You can use the MongoDB API to access Azure Cosmos DB. You can use Cassandra as an API to access Cosmos DB, so it'll look and feel like Cassandra, just like it can look and feel like MongoDB. You can also use a Graph API to access Azure Cosmos DB, in particular Gremlin. You can also access Cosmos DB using a key value pair style API, etcd, which is a popular name value storage mechanism. So basically, it's one database that speaks multiple languages, if you will, right? So you have to make a choice of what of those languages you're going to use to access Azure Cosmos DB. So aside from that, aside from this interesting aspect of, hey, it's a NoSQL database, it can speak multiple APIs. What else does it do, right? Obviously, one value is that it is on the cloud. And basically, that is the key value proposition here, right? So because it is stored in the cloud, it can actually do things that you simply would not be able to do if you were running this kind of database on-premise. Namely, that it is globally distributed, meaning you can have a single database that is actually geo-redundant if you so wish, right? So the data is available. Any piece of data that you want is basically available across the globe. Impossible to do using a relational database. It is very, very highly performant, even given the scalability, right? Even though it can reach global scale, it still will provide you some performance guarantees, believe it or not. Sometimes as little as just milliseconds to access data that's stored across the globe. That is the way Azure Cosmos DB is architected. And also the enterprise class features, so things like security, availability, and so on, right? So basically, it is a database on steroids on the cloud, right? If you really need truly just global scale and you have terabytes and petabytes of data, Azure Cosmos DB is your friend, right? This is the thing that will allow you to solve those kinds of problems, and it allows you to solve those kind of problems using all of these different languages, if you will. Okay, so now let's talk about putting these things together, right? So you can use Azure NoSQL to access Cosmos DB. In fact, instead of simply lecturing and talking about how you do this and how does the API look like, the way I'm going to do the rest of this presentation is actually do a demo for you, right? And believe it or not, this is a repeatable demo, meaning you can do this demo by yourself, right? You don't actually need me to do this demo, because I put the demo instructions on GitHub, right? So if we go back to my browser window for a moment, and I'll try not to do the crazy sort of mirror within mirror thing. But this is the URL for it. It's on my GitHub. It's on the slide deck, and I will share the slide deck location a bit later during the talk. So this is the repo. So as you can see in this repo, I've actually given you step-by-step directions on how to actually get the demo up and running. So in this particular case, I will be accessing Cosmos DB via the MongoDB API. That's what this demo shows. But basically, it'll tell you how to do the setup. I've done the setup beforehand. It's relatively straightforward. I just need JDK 11 and above. You can use any Maven capable ID. Eclipse is the one that I'm used to, so I'll be showing Eclipse. You can use IntelliJ or whatever else you want, maybe VS Code. You do need an Azure subscription because it's a database that's running on the cloud, running on Azure. You will need an Azure subscription. You can get one for 1 year for free. You don't necessarily have to pay for it, just to try things out. And you need this code, right? So I actually have this code downloaded on my machine. You can obviously hit the handy dandy button here to try to clone the database or download it as zip or whatever you prefer. But you do need this code base. Then you will go ahead and start Azure Cosmos DB, and basically you create an instance of Azure Cosmos DB. These are the steps where you can create that. I've already gone ahead and done it. Okay, so if you go into my Azure subscription, if you've never seen the Azure portal before, this is how the Azure portal looks like. In fact, I'll go to the Azure portal home. This is how it looks like. We're going to go under resource groups, which you can think of as like groupings of Azure resources in a meaningful way. Could be, you could think about it as a representation of a data center. So I have one of these resource groups here for my demo, Azure Game Store. So in this game store, this is the Azure Cosmos DB instance that I've created. Right? So hopefully you can see that. So it's Azure Cosmos DB for MongoDB account. And here's all the information about it. As you can see, I've been playing around with the database a little bit, so there's some activity going on, right? But so basically, you follow these steps to go ahead and create your Azure Cosmos DB account. Then you're going to run the application. I'm going to run the application for you, and it's relatively straightforward. It's just a Maven-based project. You can import it as a Maven-based project. There's no real runtime. I'm just using Java SC. You'll see it at a moment to run the application. In fact, all this demo really is just a unit test, right? Which I'll show you in a moment. Now, I do have to-dos here. Like I said, Azure Cosmos DB doesn't just speak MongoDB. It can also speak Cassandra and Gremlin. in my to-do here, when I get to it, I hope to create forks of my demo code that also demonstrates Cassandra and Gremlin. Haven't gotten to it yet. If you want to get to it before me, that's awesome. Right? You can just do the work and issue a PR against my repo, and I'll definitely accept that PR. Okay, so let's go ahead and take a look at the application. So here's the application. It is just a Maven application. I'll show you the POM XML, so you can take a look at it. Hopefully, you can see all the fonts. Okay, so here you can see just a normal Maven project definition. These are all my dependencies. So there are several dependencies that I'm actually pulling. This is the NoSQL mapping API, and in particular I'm using the document API. I need a driver, right? So the driver that I'm actually using is a communication driver for MongoDB in particular, right? So I'm speaking to MongoDB, so I need the MongoDB driver. I'm using the bean validation API, so I'm importing that. I'm using Weld SE, which is just a dependency injection engine for Java SE. That's all I need in this case. I'm using Hibernate Validator to do my database validation. And then there's other dependencies like expression language. I need a microprofile configuration API to be able to configure my NoSQL database using name value pairs, and of course there's JUnit. And in this case, I'm just using JUnit 4. It's good enough for my purposes. And that's about it, right? So let's go ahead and do a Maven clean real quick. Okay, and that all worked. Now I'm going to go ahead and do a Maven install or package, right? In Eclipse, it's Maven install. So I'll just go ahead and do that. And as you can see, the tests are running and they will succeed. We won't look at the tests in detail quite yet. We're going to do that actually in a much more structured way in a moment. But as you can see, this is a set of unit tests. And if you take a look at briefly, it is actually interacting with the NoSQL database. So in my unit test, I'm actually doing sort of database operations, if you will. So let's go ahead and take a look at what I am doing. Right. So let's take a look at the unit test. So you can see that I'm speaking with my Cosmos DB instance running on Azure. My unit test is going to go ahead and making that connection. So if you look at my unit test, this is how it looks like. Okay, so what I'm doing here is injecting a couple of things, right? So I'm initializing the Java SC container, okay? And the main thing that I'm looking from my dependency injection CDI engine is this document template business, okay? So I'm setting the document template over here. So I have the SC container and the document template. So in my test initialization, I'm getting a copy of the document template. Then from the template, I am actually go ahead and deleting the current data that is there. So this is a representation of the data. And then I'm deleting everything that is an order object, okay, from the database before I start my unit test. So I'm just making sure that I start from a clean slate. In my shutdown, I simply close the container. That's all I do, right? And this is kind of on purpose because I can show you the data. So after this test is done, you'll be able to see what the test did, right, in terms of the output of the data. But to begin with, I'm simply cleaning all of my data. So let's take a look at the rest of these tests. Okay, so first thing I do is I actually insert some data into the database. So this is just like creating a simple Java object, customer order, okay, and then setting the customer in the order, setting the description, creating an address object, setting the address object in my order, adding a couple of order lines, okay. So in this case, I'm ordering a pinball machine. As you can see, it's going somewhere in Pittsburgh. And there's some shipping and installation fees that are added to the order. Then I create actually insert the data using the template.insert. Okay, and by the way, the abstraction level I'm using is similar to the JPA Entity Manager. I could have used the repository API, I don't particularly like the repository API, I have to be honest. I kind of prefer the JPA entity manager style of API better. So this is the one I'm showing you, but you could have used even a higher level of abstraction. So similarly, I'm creating another order object. Okay, just ordering, adding a couple of different orders. And at the very end, I simply assert that when I count the number of order instances in my database, that I should get 3 of them. Okay, so I print that out. I say saved orders. How many did I save? Similarly, I'm doing a test find here. Okay, so this is a find by key, right? So I'm finding my one of my order IDs that I've saved off here in this test, and then simply retrieving that object, right? And then asserting that that object is in fact present. And as you can see, the Jakarta NoSQL API makes use of optionals. Okay, so I'm simply saying that this object actually exists. Similarly, you can do queries, right? So particularly in terms of one of the powerful bits of things you can do with a document-based database is basically almost get SQL-like query capabilities, right? Because basically what happens is in a document-style database like MongoDB, you can navigate the object tree, okay, and that can very much look like navigating a relational database object. And this is actually one of the reasons why MongoDB is so popular. Although it's a NoSQL database, it allows you to write these powerful type of queries. Now, depending on what type of NoSQL database, you won't be able to do these type of queries, right? So, for example, if it's just a name value database, you will have no query capabilities, right? All you can really be able to do is find by key, and that's about it. Okay, but in this case, you can. So I'm ordering I'm getting all of my order objects, and you can see it looks like very much like SQL. And then I'm adding a where clause, total cost, which is a field in my object, and seeing what is greater than 1000, right? And I'm printing those values out. How many of those do I have? Similarly, I'm looking for a description field that looks like a pinball, right? Starts with pinball. How many pinball machines have I ordered? And you can even do nested conditions as well. So yeah, I'm actually diving into the order lines, right? Remember, you can have multiple order lines given an order. And then in this case, I'm checking to see, hey, what does, in the description, do I have machine? Okay, and print those values out. So similarly, I'm doing an update, right? So I'm doing a find by ID here, and then adding a couple of order lines, adding new order lines, and going ahead and saving it. And then as a result of my saving it, I should increase my cost, right? So I'm just checking to see, hey, yeah, my cost is in fact increased when I go and refine this bit of data. And then finally doing a remove by ID as well, right? So those are the tests that I'm doing. And lastly, I'm also testing validity. Okay, so I'm creating an invalid object, right? So just an empty order object that has nothing in it. And I'm trying to save that. And what I'm testing is that attempt should fail. Okay, I should not be able to save an invalid bit of data into the database. So I will go ahead and run this test for you, run this as a unit test, and you'll see the results of it, and I'll show you the output. So run as unit test. All right, so as you can see, the unit test has succeeded, right? So all of my tests have succeeded. I'll show you the output of the tests. Let's take a close look at that. So you can see I saved 3 orders. I'm testing by ID, and I found the order I was looking for. I'm testing queries, and I'm finding 1 record of something that costs more than 1000. Only 1 record of something that starts with pinball, and 2 orders for machines, which is exactly what I expect. Okay, so all of my assertions succeeded. I'm updating the order and confirming that, yes, in fact, the order is updated. And then doing a remove of the order and deleting an order and seeing that, in fact, it is deleted. And then finally, I'm testing the validity of an order. And as you can see, I'm being told that the order was rejected, okay, because it's an invalid order. Okay, invalid order rejected. And then it's because, well, I didn't give it anything, right? The only thing that is there is just an ID, and I don't have a customer or an, or an order line. And I can also print out a nice reason code for it. Right? So these are all of the reasons why this insertion failed. Okay, so you can see that the API looks very much like JPA. So let's take a look at some of the data objects real quick. Okay, so the main object here is order, right? So the order object is just a POJO, right? As you can see, it has a few fields in it, and more or less just some getters and setters. That's about it, right? So there is the toString object also. This is what's printing out the nice rendition of my order. Okay, but other than that, we just mostly getters and setters. The way I make Jakarta NoSQL recognize this is by this entity interface. Now, this might look very similar to JPA, but it's not. Right? It's actually, in this particular case, the entity annotation is defined under Jakarta NoSQL, not JPA. But basically, entity is defining an entity for me. Just like in JPA, you define an ID. You can define what type of column it is. In this case, it's a string or total cost and what have you. And these are bean validation annotations, by the way. So if you look at not blank, these are coming from bean validation API. So I'm describing what constitutes valid data for this, for valid data in this case. And as you can also see, I can nest objects, right? So order line is, in fact, just like in JPA, it's an embeddable. Okay, but again, defined in Jakarta NoSQL. And it, again, define columns and defines what makes a valid, in this case, a valid order line. Okay, same thing for customer, right? So if you look at customer and address, right? Customer is a separate entity. Okay, and it also, again, houses some data, and then address, which is an embeddable. Okay, so very, very familiar, right? If you're familiar with JPA, you can very easily use Jakarta NoSQL as well. So it's a very, very familiar API. What else do you need to do? All you really need to do is define a factory that will allow you to create a document producer. Okay, this is how you do it. It's fairly boilerplate. There's really not a whole lot to it. This is what is allowing you to look up the document template. Okay, just mostly just fairly boilerplate stuff. So other than my unit test, the only other thing I have here is that is connecting to my database. And how do I do that? Well, how I do that just by simple configuration. So if you look at my meta-inf microfile.config properties, I'm giving it some information. So this is the name of the database. This is the name in Azure NoSQL. Or rather Azure Cosmos DB. This is a full connection string, right, that I get from my Cosmos DB instance. And here's the driver I'm using to connect. So this is the connection information, essentially. So if you look back in my Azure database, right, so this is, remember, my NoSQL in Cosmos DB MongoDB instance. There's actually a nice feature called Data Explorer. And that allows me, remember, I ran the unit test, so there is some data in here already, right? So as you can see, here's the data. There's an order, in this case, order document, okay, documents, really just, if you want to think about it, a table. And as you can see, I have two different documents stored here. So let's take a look at one of them. And let me minimize this so you can take a look at it a little bit closer. Okay, so this is how the data actually looks like. So here's my ID, right, in my Java object. Here's the zip. Here are the order lines nested objects, right? So they're literally nested objects within here. Right? These are the costs line number, right? This is literally the data stored in more or less JSON format, and these are all of the rest of the fields, including the customer, by the way. So this is the representation of how the data looks like in the database itself. So that's about it in terms of the code that I wanted to show you. And also, I'm sort of out of time, but you can again take a look at all this by yourself, right? You can log on onto the GitHub URL. So in summary, Jakarta NoSQL is a new standard for accessing non-relational databases. Cosmos DB is a planet-scale database on Azure, right? And it has multiple different interfaces. We're using one of those interfaces for the demo today. You can very easily, hopefully you can see that you can very easily put these technologies together, right, in a cloud-native Jakarta EE application. And the demo here should be a really useful starting point. I do have some resources for you here as well. If you want to find out more about Cosmos DB, best place to start is the Cosmos DB docs, as well as the Cosmos DB website on Microsoft.com. And if you want to find out more about Jakarta NoSQL, the spec, okay, that is the URL to go do that. You can take a look at what all the features of Jakarta NoSQL are. And then if you want the implementation, which is only one implementation so far, it's JNoSQL. You log on and if you log on to jnosql.org, you'll be able to see all the details of that. Now, finally, how do you get to this presentation? It's relatively simple. So there's a website called SpeakerDeck. I have an account there, right? It's very simple, Reza_Rahman, right? So my first name and last name separated by underscore. And if you look under here, here is essentially the slide deck that you just saw, right? And I'll also share my slide deck with the conference as well. So that's all I have. I really appreciate it. I'm going to stop sharing my screen, and I believe I'm essentially out of time at this point. So I'm going to stop sharing my screen. Any last minute questions? If not, I'm going to sign off soon.